Hello, everyone. Welcome to the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down, gather them up, and I will answer them here. For many of you who don't know, I mean, maybe you don't know, but my actual job is that I'm the publisher of the Universe Today website, which is a space and astronomy news website. I've been doing this job for 22 years now. We have over a dozen science writers working with us, many with PhDs, reporting on all the cool latest space news. So if you want to get more space news, go to Universe Today. Just search for Universe Today in all the places, and you should be able to find our website. All right, let's get into this week's questions. D Stonks 333. Could a satellite stay roughly in the same spot in the sky? Could it stay above a certain country or constantly on the dark side of the Earth? Yes, a satellite can stay on above a specific spot on Earth. And in fact, this happens all the time. There's a very specific name for it. It's called a geostationary satellite. And this idea was actually first thought of, we know, or we think of, by Arthur C. Clarke, the science fiction writer, who also happened to know a tremendous amount about satellites, telecommunications, and really kind of invented the concept of the modern telecommunications satellite. And he did the math and figured out that if you fly a satellite to an altitude of 35,900 kilometers above the Earth, then essentially, as it orbits around the Earth at the equator, it's the exact same speed that the Earth is turning. And so from the perspective of somebody on the surface of the Earth, the satellite would look like it was hovering motionless in the sky. And there are tons and tons of these geostationary satellites providing weather observations, telecommunications, and television broadcast. If you have satellite television, you are getting that from a geostationary satellite. But there's another orbit that's kind of similar. If you're a nation that isn't located near the equator and you've got fairly northern latitudes, you want to be able to still communicate regularly with a satellite, there's another kind of orbit. This was developed by the Russians, and it's called a Molniya. Molniya? Anyway, it's called a Molniya orbit. And how it works is that instead of having the satellite at this position and on a circular orbit around the Earth, you've got it on an incredibly ecliptic orbit at a very high angle compared to the Earth's equator. And so what happens is this satellite flies out to about 25,000 kilometers and then flies in and comes very close to the Earth, just a few hundred kilometers above the Earth, spends very little time on the hemisphere of the Earth that you're not interested in, and then flies back out on this big, long, slow trajectory, reaching its highest point. And from that, you can get your satellite to be in your field of view for most of the day, just a few hours as it passes very quickly behind the Earth. And this allowed very northern reaches of Russia to be able to communicate with satellite. A little trick here, you've got to be able to move your satellite dish fairly rapidly to track the satellite as it's moving, but still, if you aren't going to be able to use a geostationary satellite, there's this other orbit as well, and they can be used on different hemispheres of the Earth. Now, you can also use this on other planets. You could have one, say, on Mars. You could have a geostationary satellite orbiting at about 20,000 kilometers above the surface of Mars, and same thing. Mars is turning, the satellite is in the exact same spot in the sky. And I'm sure when we have some future civilization on Mars, we'll be using those geostationary satellites from there as well. Colin Houseworth. If evidence was discovered that the universe is in fact infinite, wouldn't that also answer the Fermi Paradox, since there would be another version of us out there? Maybe even one a long time ago in a galaxy far, far away. Nice Star Wars reference there. Yeah, so there are two possibilities. One is that the universe is finite. It has a very specific size and kind of wraps on itself like a 3D game of asteroids. And the other possibility is that the universe is infinite, goes on forever in all directions. And right now, astronomers don't know which of these is the correct answer. You know, if pressed, most of them would think that it's probably infinite, but we actually have no definitive answer either way that you can point with evidence and say the universe is finite or the universe is infinite. And one of the weird implications of a universe that is infinite is that there is a finite configuration that matter can have in a volume of space. And so if you have, say, a cubic meter of space, you're going to have all of these different configurations of particles. You could have the kinds of particles, the spin, the level of magnetism, the position, the velocity, all of this. And it turns out there is a finite number of pieces of information that you can use to describe matter in some area of space. If the universe is infinite, then you're going to get a situation where if you go far enough, and like it's like a really long way, you're going to get a repeat of one of these finite meters of space. And if you go even farther, maybe you're going to get a repeat of 2 meters and 10 meters and 100 meters and 1,000 meters and 1,000,000 meters. And the implication is that if you go far enough in any direction, you're going to start hitting repeats of stuff in the universe. Anything that can repeat will repeat an infinite number of times. Now, you can't get things that are impossible. So you can't get, say, unicorns, but you can get, I guess a horse with a horn is not that impossible, but like a magic horse with a magic horn. But anything that is possible, like the Earth, like regular horses and regular horns, you're going to get these an infinite number of times and every variation thereof. And so somewhere out there in the infinite universe, there's an infinite number of Frasers having an infinite number of podcasts right now. And absolutely, that would totally make the Fermi Paradox irrelevant. Where are all the aliens? They're out there an infinite number of times in every variation thereof. It's just that they're too far away for us to reach. They are way beyond the cosmological horizon, and so we could never communicate with them. Hakon Bogen. When a moon is heated by tidal forces like Io, where does that energy come from? Does every heating slow its orbit a tiny little bit? Yeah, so we know that Io is the most volcanic place in the solar system. It's covered in volcanoes. And then we know that Europa is heated. It has geysers. It has an ocean of liquid water underneath a shell of ice. Callisto, Ganymede, each of those are also heated up. And this is happening because of tidal heating from their interactions with Jupiter. And what's exactly happening is that Io is orbiting Jupiter so closely that the front side of Io is getting pulled differently compared to the backside of Io. And you have this tidal flexing that's going on. It's sort of like pulling Io into like a teardrop. And that alone would cause tidal heating. But as you said, you would imagine that it would eventually settle down. Io would reach its perfect spot where it's tidally locked to Jupiter. It's orbiting over the exact same spot. There's no more variations. And so you're not going to get any more flexing. But because of the rest of the moons, they are causing irregularities in Io's orbit. So every time Io goes around, it interacts with Europa and Ganymede and Callisto. And so it gets pulled back and forth through the interactions with the moons and with Jupiter. And it's that interaction that causes it to sort of flex in and out and in and out. And that causes the moon to have huge amounts of magma under the surface, and less so with Europa and so on with the rest of the Jovian moons. And a similar situation is probably happening with Enceladus, and really any place where you're going to have a large moon or moons close to a planet with a lot of mass. And similar probably with planets that are orbiting around stars as well. If they're close enough, they're going to have these tidal forces. They're going to be extremely hot and interacting with other planets as well. Ivan Medina. Is there an asteroid hitting us on the 11th? If you pay attention to space and astronomy news, and in fact, if you kind of don't, if you just like pay attention to social media, you're going to see these kinds of stories come up all the time. And I'm not going to name any names, but there are a lot of newspapers and online magazines and things like that that have learned that if they write a story about NASA detecting an asteroid coming very close to the Earth, they clearly are getting a lot of clicks, and so they're getting a lot of traffic to their website, they're getting a lot of advertising revenue, and there's lots of money made by scaring people thinking that the asteroid Armageddon is about to happen. And the reality is that it's not. There is an asteroid out there with our name on it. At some point in the next few tens of millions of years, one will collide with the Earth and cause a very bad day. But that day is not soon, and nobody knows when this is going to be happening. But large asteroids and small asteroids come very close to the Earth all the time. And so I think the one that you're talking about is one that is coming 10 times the distance from the Earth to the moon. So the Earth and the moon is about 300,000 kilometers apart. And this asteroid, I think, is coming within 3 million kilometers of the Earth. That is not close. That is not dangerous. That's fine. And you get these stories all the time. And in fact, asteroids come within that distance on a regular basis. And in fact, they come much closer than that. Sometimes we see asteroids come within the distance between the Earth and the moon, sometimes within a quarter of the distance of the Earth and the moon, sometimes even closer than that. This happens all the time, and it's nothing to be worried about. So don't pay attention when these people are trying to scare you, is, I guess, the bottom line. That said, learning about the asteroids that are around our neighborhood is a pretty good thing to do. And so NASA and other astronomy groups have built robotic surveys that are watching the skies, charting the positions of known asteroids and helping to discover new ones. And of course, NASA's DART mission, which just launched a couple of weeks ago, is going to try impacting the moon of a tiny asteroid to see what happens when you try to collide with it. Can you move it off of its existing trajectory? What would it take if we did discover an asteroid that was on a collision course with Earth? What would it take to actually be able to shift it away from its orbit and keep us safe? So ignore all of them. They're all just trying to scare you, to get you to click their website and to earn them money. But definitely pay attention to just the unfolding science and all the interesting things that there are to see in the night sky. Zach, do galaxies traveling apart travel faster than light? In some cases, yes. So here in our local group, we've got the Milky Way, Andromeda. Andromeda's moving towards us. It's about 2.5 million light years away. We've got Triangulum, M33, so another large galaxy, then a bunch of dwarf galaxies that are orbiting around in this area. And then you've got, as part of the Virgo supercluster, you've got other galaxies that are in the tens of millions of light years away from us. And those are all moving away from us. And what astronomers discovered, of course, this was the big discovery made by Edwin Hubble back in the 1930s, was that the farther a galaxy is, the faster it's moving away from us. And in fact, once you get into several billions of light years away from us, the galaxies that you're seeing today are actually now receding away from us at a speed that is faster than the speed of light. And obviously, things can't move faster than the speed of light, but it's not. The galaxy is moving at its normal speed. It's being carried away by the expansion of the universe. It's just that its apparent speed to you, because you're also, we here on the Milky Way are moving away because of our part of the expansion of the universe, as well as them on the other side of the universe. When you add that up, if you measure the velocity between these two galaxies, it is greater than the speed of light. So yeah, in theory, there are many galaxies out there that are moving away from us faster than the speed of light. Nunya Bee's Knees. Is there an antimatter equivalent to photons? If so, could that be a potential candidate for dark energy? For various kinds of matter, there are an antiparticle of that matter. And this is a thing that physicists can produce in the lab. Not a lot, but they can do it. And in fact, it's used for practical purposes. So in a lot of hospitals, they have a particle accelerator that can generate positrons, which are antimatter versions of electrons. And these, as they move through your body, they interact with regular matter, they release a little bit of energy, and doctors can use that to map out the interior of your body. So antimatter is a thing that is made and used for modern medical science and other purposes as well. But physicists have been able to create antiparticles of protons and other particles. But they don't do it with photons. And the reason is that the photon is actually its own antiparticle. So there is no antiparticle to the photon. It is its own antiparticle. And would that be a candidate for dark energy? No, because we see photons. Winston Montgomery. Is it possible that we can start calling rocky bodies in our solar system that are the size of Pluto planets? People have heard me talk on Astronomy Cast and other places. I'm totally over this controversy about what is a planet and what isn't a planet. I just don't care. Each world, and I've sort of been taken to calling them worlds is fascinating on its own right. And there are plenty of really legitimate reasons why you would call anything that has enough gravity to pull itself into a sphere to be considered a planet or a world. If it orbits around the sun and it can pull itself into a sphere, then it's significant and is worthy of the term planet. Or not. I don't care. But back about 20 years ago, when astronomers were first discovering the vast amounts of objects in the Kuiper Belt, this place around where Pluto orbits, they were finding tons of these things, and they were briefly calling them like Plutoids, I think was the term. And then they settled on dwarf planets. So you've got rocky planets, gas planets, ice planets, dwarf planets, and cool moons. But in my opinion, they're all just worlds. Whether we have 8 of them or whether we have 150, there's the more the merrier. Alexandru Vataman. As we all know, our sun will keep getting bigger in time. In this case, what would be the possibilities for future generations to keep the Earth at the right distance? I mean, to move it further. Yeah, that's a pretty significant project that you want to take on. Astronomers understand that the sun is heating up, and this is happening because inside the core of the sun is turning hydrogen into helium. The helium is building up almost like ash inside the core of the star. It's causing the core of the sun to expand a little bit, and that's causing the overall luminosity that's being given off by the sun to increase. And we are receiving more temperature. And I've talked about this before. This has nothing to do with global warming. Global warming is happening on the scale of decades, while this overall increase of luminosity from the sun is happening over hundreds of millions of years. But the bottom line is that in about 500 million to a billion years, this will have heated up to the point that the Earth is uninhabitable. And that sucks because you've still got another, say, 5.5, 6, 7 billion years before the sun itself actually dies. And so wouldn't it be better if we could keep the Earth habitable for this entire time? And the solution is that you move the Earth outward from the sun, which sounds mental, but it's actually theoretically possible with the kind of technology that we have soon. And so what you would do is you would find an asteroid that's on the perfect orbit. You'd have that asteroid fly past the Earth and give the Earth a bit of a boost in its orbit. So you'd essentially be speeding up the Earth's orbit. And what that would do is that would actually cause the Earth to raise its orbit, slowing its orbital velocity down a little bit, but don't worry about it. So now the Earth would be a little farther away from the sun, and now you've got this asteroid. Now you could take this asteroid, if you get the angles just right, this asteroid would then fly back out, all the way back out to, say, Jupiter, steal a tiny little bit of Jupiter's orbital momentum, and then kick back around and come back towards the Earth and donate a little bit of that momentum to the Earth. And then the Earth would be shifted out a little bit more and would cool down a little bit. And you could either do it with one asteroid, just ferrying it back and forth between Earth and Jupiter. If you get the timing right, you know how far you need to have it come past the Earth and past Jupiter to work out all the orbital mechanics. The other possibility is you could just use a different asteroid every single time. Just keep shifting asteroids to come really close to the Earth, and they would slowly push the Earth further out. And the math was something like you would need to do it like one in every 10,000 years to maintain a constant pace of keeping the Earth farther and farther away from the sun as the sun is heating up. And it's theoretically possible, but it's one of those gigantic mega projects that we will have a hard time actually carrying out. But at some point, as weird as it sounds, that's a thing that humanity might have to figure out if we want to be a billion-year-old civilization. More questions in a second, but first I'd like to thank our patrons, Pamela Morgan, Morag Williamson, Chika Takami, and the rest of our 783 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Joseph Brudlos. Could you make a small-scale magnetic field generator to protect Mars bases and spaceships? I heard that it would take a relatively small magnet to protect a ship years ago. This is one of those ideas that has been floating around for decades, that we know that the Earth is protected by a giant global magnetosphere, which blocks cosmic rays, blocks the solar wind, and really protects us from all of the radiation that's out there in the universe. And if you were outside of this magnetosphere, unprotected from radiation, you would receive lethal doses of radiation during giant radiation storms. You would receive increased amounts of radiation leading to cancer. It's bad. You need to be under some kind of either radiation shield or dirt or water. Just a lot of protons between you and the radiation. And literally from the 1960s onward, NASA, the European Space Agency, have been trying to figure out a way to build an artificial magnetosphere that they could put on top of a spaceship. It seems simple, right? You just put some kind of magnet, maybe a superconducting magnet, and run electricity and generate some kind of magnetic bubble around the spacecraft. And I've seen various iterations of this idea. In some cases, it's a device that is then generating this field. In other cases, you've got like a coil that's wrapping around part of the spaceship and the astronauts live inside this thing, or it protects the whole spaceship. But every time people try to work this out, the math ends up being that it's better to just carry lead or metal, or just have water supplies, things like that you can huddle around yourself while you're experiencing a fairly bad proton storm from the sun. And then as soon as the storm is over, then just put your water back in its cabinets and continue on with your mission. The same thing with Mars. You know, it's much more feasible to live underground on Mars than to try to generate the power needed to protect yourself with some kind of electromagnetic field. Already on Mars, power is going to be really difficult to come by. It feels like Mars is just this sun-parched desert wasteland, but the reality is that Mars is a lot farther away from the sun than the Earth is. And so we have tons more solar power than Mars does. They're going to have vastly bigger solar panels to be able to produce the same kind of solar energy, or they're going to need to run nuclear power plants, and they're going to have a lot of things to use that. They're going to need to be doing electrolysis to break apart their water. They're going to need to be breaking apart minerals. They're going to be breaking up the regolith. They're going to need to be making water and food and heat in the terrible temperature and running pressure and recharging all their vehicles and so on. So right now, this has been a really tricky problem. I have done many videos about this. I could point you at dozens of papers of people trying to crack this problem. NASA has spent money as part of several programs to try to crack this problem. The European Space Agency is working on a version as well, and nobody has been able to come up with a solution. But, you know, if you can, then there's tons and tons of funding waiting for you to figure it out. Elshar 666. If all humans vanished today, do you think that we'd leave any evidence behind that we ever existed in 1,000,000 years? Our existence on the Earth would be wiped away by the natural forces surprisingly quickly. That if all humanity disappeared, you would end up with plants, trees, starting to take over pretty much all spaces. I mean, we see plants can live on top of concrete, things like that, break it apart, metal rusts, plastic gets worn away. And within 1,000,000 years or so, no, it would be really tricky to see any evidence that there was any human beings on the surface of the planet. Even fairly big monuments, the pyramids, would be worn away by sand and wind and water. It would be pretty tough. In fact, there's an interesting idea that are human beings the first technological civilization on Earth? Was there some super smart species of dinosaurs that came before us? And the problem is that there aren't a lot of places which aren't regularly resurfaced here on Earth. The Earth is trying very hard to reclaim the entire surface of the planet. There's this paper looking at this idea of, could there have been another technological species? And the reality is there could have been before us, and we probably would have a hard time finding evidence of their existence. So when humans wipe themselves out and the squid take over, or the dolphins or whatever, they may think that they're the first technological civilization that's ever existed on the Earth. Now, there's some places where it would be more obvious. There are satellites in space that could be orbiting for hundreds of thousands of years if you get the right orbit. You could put things on the moon that'll last for a long time, millions of years, billions of years. So if they went to the Apollo landing sites, they'd be able to find the Apollo landers. But down here on the surface of the Earth, yeah, we would be wiped away pretty quick. Dark by design. Do you wish to live 200 years from now to see all the discoveries? I do. People always ask, like, would you like to travel back in time or forwards in time? If you had to pick one, I always want to go forward in time. I love to see the changes that are happening, the good changes. I'm sad and disappointed by the bad changes, but I'm excited by the good changes that are happening with technology, with our developments in space exploration, the new discoveries that are being made. And things are accelerating, but I also definitely feel like I'm getting older. I just turned 50 this year. So who knows how many years left, how many decades left I have on this planet to be able to be a part of this. Yeah, I would love to go 200 years into the future. If you could guarantee me that there is a future 200 years from now and I could press a button, but I mean, I've got my family, my wife, so I don't think I would press the button to go 200 years into the future, but I would love to know what the future holds. I can't wait for all the interesting things that are happening. Thomas Sonini, why are the rocket stages launched facing up and then decoupled, rotated, and reassembled in orbit instead of being launched in their final arrangement? I don't know if this is a thing that happens on a regular basis, but the one that was done like this was during the Apollo program, when the Saturn V would launch with all of the stuff on the top of it, topped by the capsule. And then once it got in orbit, once its various stages had been removed, it would detach, turned itself around, pulled the lunar module out, and then with this new stack, it fired and went to the moon. And, part of the reason is that, when you look at the shape of a rocket, you want to have the pointy end at the top. And the pointiest part is the return capsule. And then you put everything behind that. But you also need to have a rocket engine for the command portion. You need a rocket on the lunar portion, on the ascent stage. And so that was the configuration of how they were going to unfold these various pieces as they reached the moon, performed their mission, and came back to Earth and re-entered the atmosphere with the capsule. So that's why everything was the shape that it was. But I don't know of other examples where they go through this maneuver where they pull the rocket apart and reorganize it. When Starship finally flies, and if they get to this future version where it's refueling, the plan is the Starships will launch. One will be in orbit, another one will come up beside it, or maybe they'll go end to end. I'm not sure what the current idea is. They'll refuel each other, and then one will return back to Earth, and another will come up and refuel it, then come back to Earth, and then the rocket will continue on to its final destination. So I think you're just seeing one stage, the Apollo missions, and that won't be the configuration that all rockets have to use. It's just depends on the mission. Scurvy Sam, what's the largest telescope Starship could launch? So the launch fairing of a standard rocket, like an Ariane rocket or a Falcon, is 5 meters wide. And that's why James Webb has the appearance that it does. It's designed to fit and fold within an Ariane's 5-meter fairing, while Starship is expected to have a 9-meter fairing. And so you could have a telescope that is roughly twice as wide before. And so it would allow you to launch telescopes much more similar in size to James Webb. Like James Webb's main mirror is 6.5 meters wide. And then its sun shield is gigantic. But in order to fit James Webb within the 5-meter fairing of the Ariane space, even the main mirror had to fold up and be able to be deployed. But in theory, if it was in Starship, you could launch without having to fold it up. And people have tried to figure out ideas of like, what's the biggest version of LUVOIR that you could launch inside a Starship? And you could have an enormous space telescope. You might have to fold it up similar to James Webb, and now you've got a 15-meter, 20-meter telescope. The next generation of big space telescopes are going to be assembled in orbit. They're not going to be launched in one go like James Webb or Hubble or Nancy Grace Roman. They're going to be assembled in orbit, kind of like the International Space Stations. You're going to launch one part, maybe the main bus, and then you're going to launch more parts, the mirror, and then the bus is going to have robotic arms, and it's going to be able to grab all these pieces and assemble a telescope around itself. And NASA has worked on some proposals to actually do this, and it seems pretty feasible at this point. Edward Casimir, what is the ultimate source of the energy that causes the planets to orbit the sun? How do these bodies obtain this kinetic energy? Well, you kind of have to roll back the entire history of the universe to figure out where all of this energy is coming from. And it's essentially coming from the Big Bang, I guess. So, during the Big Bang, all of the matter in the universe was created, and then it's expanding away from each other out into space. But each one of these individual little particles has its own movement going through the universe. And all these little particles are collecting together with each other through mutual gravity and forming blobs. And so if you average out all of the motion of all of these different particles that are inside this giant nebula cloud of gas and dust, you end up with what will become the final direction of rotation of this galaxy or this solar system or what have you, or planet. And so you've got this giant cloud of gas and dust, say at a solar system level, and then through mutual gravity, it's starting to collapse and compress down. And the classic thing that people always use is that it's sort of like a skater pulling in their arms. As they pull in their arms, they go faster and faster and faster. And so you've got this cloud of gas that's getting smaller and smaller. It's spinning up faster and faster. As it spins up, it flattens out into this disk, kind of like a record. And at the center of this is the sun, and then surrounding this is all this other material that's part of the planetary nebula. And then inside this planetary nebula, all of these particles are bouncing into each other and clinging together into larger and larger objects, turning into planets. And then the planets eventually clear out their orbits, and now they're moving and going around the star. What helps them keep moving? It's just momentum. There's no friction. As Newton said, an object in motion tends to stay in motion, and an object at rest tends to stay at rest. There is nothing to stop them. There's no friction. They're not bumping into anything. So they just keep moving around and around and around, held by the gravity of the sun. So what is the source of the energy? Like the leftover velocity and momentum from their existence at the Big Bang, I guess. Dico Ravento. Will Starship wreak havoc on planetary protection with its massive size and the possibility that the first attempt landing on Mars might be explosive? I mean, when we're at the point that starships are flying from Earth to Mars, there is no way that they're going to be able to be cleaned at the level that is required to perfectly prevent planetary infection. You're going to get contamination of Earth life into Mars. If there's any hospitable environment on Mars at all, our hardy bacteria, cyanobacteria, our fungi, our water bears, they're going to find a way and they're going to survive on Mars. We know that Earth life can survive on Mars. So it feels like it's just kind of a matter of time. And NASA and the European Space Agency and the Chinese, etc., when they build a rover that's going to go to a place that you could potentially contaminate life with Earth life forms, they clean their spacecraft very carefully. They take them apart, they bake them in a autoclave, they clean them with alcohol, they try to remove any possible life, and then they assemble the spacecraft bit by bit in a giant clean room, and they try to minimize the number of bacteria particles that are on any one of these spacecraft. And when you've got like Starship and you've got all these people loading on board and you've got all this stuff and supplies and the Starship is launching, there's no way they're going to be keeping it clean. And so if life can contaminate, then it will. And at that point, all bets are going to be off. So this is another one of those situations where Elon Musk is just making decisions unilaterally for science and humanity. And it would be nice to come up with some strategies on how to minimize the chances of infecting Mars with Earth life. And the best idea that I've seen is that you just create an exclusionary zone. You find a place on Mars that you're fairly sure is very inhospitable, and then you arrive with very clean spacecraft. You examine very carefully in an area, make sure that there's really no life forms in the rock, under the rock, dig down tens of meters, search for any evidence under the regolith, and then create a zone which you have said is safe. You make sure that people don't go outside of that zone while they're beginning and can do more and more exploration. And then you slowly expand your zone as you learn more and more about Mars. And hopefully that's what will happen. Lou Perez, why can't we find the ninth planet? It's not very bright. It's really far away and it's really hard to see. And astronomers have used the most powerful telescopes that they can to scan as much of the area where they think Planet 9 is, and so far they haven't found it. They think it's there because they can detect its interactions with the other objects in the Kuiper Belt, but they haven't been able to actually find it. And it might mean that the orbit's a little off than what they're expecting. It might mean that it doesn't exist, and there's some other explanation for why the orbits of all these other objects out there have been perturbed. And it might just mean that we need better telescopes, that it is darker, it is less reflective of sunlight than astronomers were calculating. Maybe it's smaller than we're anticipating, and it's just going to require a better survey. The tool that's probably going to find it, the observatory, is going to be the Vera Rubin Observatory, which is this enormous, fast telescope that's going to be coming online next year in 2022. And it's going to be scanning the entire southern sky every couple of nights and should be the one that will find Planet 9 and more out in the outer solar system. So this is kind of how science works. You have some predictions, you follow up with observations, and you can either confirm them or deny them depending on what evidence you're able to gather. So hopefully we will learn of Planet 9 in the next couple of years. It'd be great if we did. All right. Thank you, everyone. Those are all the questions that we got this week. Super fun, as always. Remember, if a question pops in your brain anywhere across my channel, just write it down. I'll gather them up. I'll answer them here. And if you want, join me every Monday at 5 p.m. Pacific time, and we'll do the show live. And you can ask your questions here and even do follow-up questions. It's a lot of fun. And it's a much longer show. So come and join me on the next live stream. And I'm sure there'll be a notification for the next live stream somewhere around here. All right. We'll see you next week. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber and Nancy Graziano.